Morning everyone. Welcome to Guru Brahma classes for JEE and NEET. In this session we are going to learn about work done when a curve or graph is given. So let us see here. This is PV diagram. So PV diagram is also called as what? Indicator diagram. Area under PV curve. So area under PV curve represents work done. Okay. Area under PV curve. So let us take on y-axis what is taken pressure, and x-axis what is taken volume. This P into V gives you the area. Already we have studied that the basic formula to calculate the work done, mechanical work done, is given by minus P external into V final minus V initial or delta V. So if work is done by the gas, then that is expansion work, and that will be negative. And if work is done on the gas, then that will be compression, and the work done will be positive. So here there is a PYQ question which is asked in JEE 2020. So let us see that. The magnitude, he is asking only magnitude, the magnitude of work done by the gas that undergoes a reversible expansion along the path ABC. So a process has moved from state A to state B and from state B to state C. So from A to C is asking what is the amount of work done. What will be the amount of work done? This area, this total area, if you can calculate this total area, then that will be the work done. So this total area can be calculated in the way that if you can calculate the area of the square ABDE and area of triangle BCD, and if you add those two areas, then that will be the area under this curve. Okay, so let us calculate that. So work done, we are calculating work done, right? So to calculate work done, we have to calculate the area of PV curve or PV graph. So first of all, you have to calculate area of square. What is that square? ABDE plus area of triangle BCD. So how to calculate the area of square ABDE? Then that will be area of square is given by A square, where A is the side. So one of the side is see, pressure. Pressure has moved from 2, initial pressure is 2 Pascal, the final pressure is 8. So 8 minus 2 Pascal into, right? Here on x-axis you see initial volume is 2 liters, the final volume is 8 liters. So but the question is given in meter cube. That means initial volume is 2 meter cube and final volume is 8 meter cube. So 8 minus 2 meter cube, right? So this will be the area of the square ABDE plus area of triangle. What is the area of triangle? Half into length into breadth. Okay, so let us take this as x-axis as length and y-axis as breadth. X-axis, if you take volume for this triangle, initial is 8 and final is 12. So 12 minus 8 meter cube, okay, into breadth. Let us take y-axis. On y-axis for this triangle, the final pressure is 8, initial pressure is, final pressure is 8, initial pressure is 2. So again 8 minus 2 Pascal. So we have calculated this into this, right? Then what do you get? 8 minus 2, 6 Pascal into 8 minus 2, 6 meter cube plus half into 12 minus 8, 6 meter cube into 8 minus 2. 12 minus 8 is, what is 12 minus 8? It is 4. 12 minus 8 is 4. 8 minus 2 is 6 Pascal, right? 6, 36. How much? 36 Pascal into meter cube plus half into 6 fours, 24 Pascal into meter cube. So 12, right? 36 plus 12 is equal to 48 Pascal into meter cube, right? So 48, but the question asked is shown in the figure is dash. We have to calculate it in joules. Joule. 48 into, so 1 Pascal into meter cube. 1 Pascal is equal to 1 Newton per meter square into meter cube. So meter square cancel. Then what do you get? What remains? Meter remains. Then that is equal to, okay, work done is equal to 48 joule. Actually work done here is A to B is expansion, B to C is also expansion. A to B is expansion, B to C is also expansion. So expansion work already we have studied that it is negative. So actually it is work done by the gas which is equal to minus 48 joule. But the question asked is only magnitude. So what is that? Magnitude minus plus 48 joule. So answer will be what? 48 joule. Understood? Right? Next question. So if you look into the next one, let us see this. Okay. In this, an ideal gas undergoes a cyclic transformation starting from the point A and coming back to the same point by tracing the path A to B, B to C and C to A as shown in the diagram of the total work done in the processes. So what type of process is this? This is called as what? A cyclic process. What process is this? A cyclic process. Cyclic process. So what is cyclic process? Cyclic process in which the initial state of the system is equal to final state. What is that? Initial state is equal to final state. Initial state of the system is equal to final state, right? So initial pressure is equal to final pressure, initial temperature is equal to final temperature, initial volume is equal to final volume. In this way, in a cyclic process, the properties which are responsible or which defines the state of the system, initial properties are is equal to final properties, right? So this pressure, volume, temperature, number of moles defines the state of the system. So the properties which define the system, those properties, initial properties will be equal to final properties. See, let us take one graph. See, we are taking PV graph. In this PV graph, initially at state A, there is state A of the system. It has converted to state B. And from B to, again it has converted to another state C. C to D. Again from D to A. D to A. So A is the initial and A is the final state. In such cyclic process, what do we get? In cyclic process, the initial state is equal to final state. Then when you draw a graph between P and B, we get a loop like this. Even let us draw another graph for cyclic process PV. The system has started from state A, moved in this way to state B. Again from B to, again it has moved to A. A to B, B to A again. Now this is also called as a cyclic process. In the cyclic process, what is the work done? Work done, we have studied that it is a path function. It depends upon the path. It does not depend upon the state of the system. It is a path function. As the system is following different paths, the work done will not be equal to 0. There will be some work done because work done is a path function, path dependent property. So this area gives you work done under cyclic process. Here also this area gives you work done. So work done can be calculated by calculating the area under PV graph. Okay. So in the question given to us, let us see. What is the question? Cyclic process is given here. It is given cyclic process. The cyclic process, if you can calculate the area of this, say this area ABC, then that will be the work done. So calculating area of triangle ABC. Area of triangle ABC is equal to half into, okay, half into AB into AC, right? So half into AB is 30 minus 10 decimeter cube into AC. AC is 30 minus 10, okay, kilopascal. That is equal to half into 30 minus 10, 20 decimeter cube into 20 kilopascal. So that is equal to half into 20, 400 kilopascal into decimeter. So half into 400 gives you 200 kilopascal into decimeter. So now coming to the relation between decimeter cube and meter cube. So 1 decimeter is equal to 10 power minus 1 meter. Decimeter cube is equal to 10 power minus 1 meter whole cube. Then what do you get? 10 power minus 3 meter cube. So 200 kilo means 10 power 3 Pascal means Newton per meter square into 1 decimeter cube is equal to 10 power minus 3 meter cube. Okay. 10 power minus 3, 10 power 3 cancel. Then what do you get? 200 Newton per Newton into meter. So 200 Newton into meter gives you 200. Right? Understood? So next, let us go with the next question. So here is the question again. According to the graph, from the graph we can understand that it is again cyclic process. We can understand that it is what process? Cyclic process. So the question asked is the magnitude of the work done. 1 mole of an ideal monoatomic gas is subjected to changes as shown in the graph. In this graph, it is described. So what is asked is the magnitude of the work done by the system or on the system. So he is asking only as the magnitude. Okay. In this, we need to solve the question in a different way. So finally, you need to calculate the area under the graph. Already we have studied the area under the graph, under the PV graph gives you the work done. Here, how to solve the question is that total work done. The process moved from A to B, from B to C, and C to A. So work done total can be written as work done in the process A to B plus work done in the process B to C plus work done in the process C to A. Right? So first of all, A to B, let us take A to B. If you see A to B, pressure is constant. So what is that process called as isobaric process? What is the process called as isobaric process? In isobaric process, delta P is equal to 0. Okay. Then work done in isobaric process is given by work done is equal to minus P external into V final minus V initial. That is equal to external pressure. Pressure is 1 bar into V final. Final volume is 40. A to B, no? So 40 liters minus 20 liters. Initial volume is 20 liters. So that is equal to minus 20 bar into liter. Right? So what did we get? Work done in the process from A to B. Next then work done in the process from B to C. So B to C, if you see B to C, volume is constant. So what is the process from B to C? The process from B to C is isochoric process. Isochoric process. So isochoric process V initial is equal to V final, where delta V is equal to 0. So work done B to C is P external into delta V, that is equal to P external into 0, that is equal to 0. So work done in the process B to C is equal to 0. Next, coming to work done in the process C to A. So work done in the process, first of all we have to see what is this process C to A. What is this process C to A? So C to A is isothermal process. Isothermal. In this isothermal process, okay, isothermal process which is reversible, and C to A is compression work. not expansion. C2A is compression. It's not expansion. But A to B is expansion. A to B is what? Expansion. Isobaric process. This is expansion, but whereas C2A is compression, right? So we have studied one formula to calculate work done for reversible isothermal process. Work done in reversible isothermal process C2A is equal to minus 2.303. So when you derive, if log here log 10 is given as 2.3. If log 10 is given as 2.303, then we have to take 2.303. During derivation, we have studied that. Here given only log 10 is equal to just 2.3 given. So we are using only 2.3 here, right? So 2.3 into nRT log V final by V initial. That is equal to minus 2.3 nRT. So here the gas given is ideal gas, right? You see ideal gas is given. For ideal gas, we can ideal gas. If you take ideal gas, we know that PV is equal to nRT, ideal gas equation. Instead of nRT, we can use PV. So instead of nRT, I can use PV log V final by V initial. That is equal to minus 2.3. It is isothermal process. In isothermal process, okay, isothermal process, PV is equal to constant. So P initial V initial is equal to P final V final. Okay, either you take 40 into 0.5 or you take 20 into 1, the same, it will be same. So let us take, it has started from C, 40 into 0.5, 40 into 0.5 log, final is 20, but initial is 40. This is compression. So final volume will be less. So 20 by 40. If you move 40 up and 20 down, then you will get plus instead of minus. So work done is equal to 2.3 into 20 to 0.5, 20, okay, liter into bar, bar into liter, into log 2, because we have moved 40 up, numerator, 20 to denominator, so that this minus becomes plus. So then what you get, 2.3 into 20 into log 2 given already, 0.3 in the question, bar into liters. If we calculate this 20 into 2.3, 236, 2 2 is 4, 46, 46 into 0.3 bar into liter, and that is equal to 6 3 is 18, 3 4 is 12, 13. So we get 13.8 bar into liter, right? So work done total is equal to minus First process A to B. A to B, how much did we get? 20 bar into liter plus 0 plus 13.8 bar into liter. So then that what do you get is minus 26.2 6.2 bar into liter. But the question asked is in joules, right? So here is a joule. And this is a JEE 2023 question. Okay. Right. So how many joules do we get? So let us calculate what is bar into liter. 1 bar into liter. 1 bar is equal to, so question given as what n bar. Bar is equal to 10 power 5 Pascal into liter is equal to 10 power minus 3 meter cube. That is equal to 10 power 5, 10 power minus 3, 100 Pascal into meter cube. That is equal to 100 into 10 power 100. See, let us see. 1 Pascal is equal to Newton per meter. Newton per meter into meter cube. That is equal to 100 Newton per meter square. 100 Newton into meter. That is equal to 100 joule. So 1 bar into liter is equal to 100 joule. So minus 6.2 into bar into liter is equal to 100 joule. That is equal to, okay, 620 joule. But in the question also only magnitude is asked. So magnitude of work done will be 620 joule. Okay. Also understood. Let us go to the next question. So next question is asked in 2025 JEE mains. So what is the question? Perfect gas or ideal gas, number of moles is 0.1 mole, right? 0.1 mole. Next, having CV is equal to, CV is given 1.5 R, independent of temperature, undergoes below transformation from 0.1. So this is the 0.1 to 0.4. To 0.4. If each step is reversible step, the total work done while going from 0.1 to 4 is minus already given. So how many joules? So given R value 0.082 liter into atmosphere per Kelvin per mole. Right? So again the graph is between V and P and V. So total work done. So work done total will can be given by work done during the process 1 to 2 plus work done during the process 2 to 3 plus work done during the process 3 to 4. So process 1 to 2, let us take 1 to 2 volume is constant. So what is that? Isochoric process. So choric process. Already we have studied that isochoric process delta V is equal to 0. So work done is equal to 0. Right? Process 2 to 3, let us take. Process 2 to 3. Process 2 to 3 is isobaric process. What is that? Isobaric process. Isobaric process. So work done is given by minus P external into V final minus V initial. So at an external pressure of 3 atmospheres. Minus 3 atmospheres. V final is given as 2 liters. 2000 centimeter cube, no? Centimeter cube means 2000 centimeter cube, 2000 ml. 2000 ml, right? So 1 centimeter cube is equal to 1 ml. 2000 centimeter cube is equal to 2000 ml. This is equal to 2 liters, right? So 2 liters minus 1 liter, that is equal to minus 3 atmospheres into liters, right? So if you want to convert it into joule, as the process from 2 to 3 is expansion work minus. So let us convert atmosphere into joule. So 1 atmosphere into liter into joule. 1 atmosphere into liter. 1 atmosphere is equal to 1.013, right, into 10 power 5 Pascal, into 1 liter is equal to 10 power minus 3 meter. That is equal to 10 power 5 into 10 power minus 3, 1.013 into 10 power 2 Pascal into meter cube. Okay. Then 1.013 into 10 power 2, you get 101.3 Pascal into meter cube. That is equal to 101.3 Newton per meter square into meter cube. Then 101.3 joules. Do we get 101.3 joules? Then work done given by minus 3 into 101.3 joule. That is equal to minus 303.9 joule. So this is the work done in the process what 2 to 3. Process 2 to 3. This is the work done. And coming to work done in the process 3 to 4. Work done in the process 3 to 4. What process is this? Again, volume is constant. What is that? Volume is constant. So isochoric process. Isochoric process. As it is isochoric process, delta V is equal to 0. So W is equal to 0. So total work done is 1220. 223 is minus 303.9 joules. And 3 to 4 is again work done 0. So total work done. But what is the question asked? Already minus, no? So nearest integer is asked. So what will be the nearest integer? 3.9, 3.4. Answer will be 304. Okay, understood? So these are the problems given in JEE mains in the previous years based on the PV graphs. I hope so everyone understood. Thanks for watching up to the end of the video. If you like the video, please like, share and subscribe. Thank you. We shall meet in the next session. Okay.